Hi there, and welcome to lesson number 6 in the series Learn How to Code with Python. Up till this point, I've shown you some basic principles of coding, and I've showed them while using Python. And in this lesson, we will go into some specific Python things that you need to know. For instance, where the place where we type the Python commands is called the interpreter. Sometimes I've called it engine or something else, but in general it's called the interpreter. It interprets what you type and then processes it in the Python interpreter and gives you back something, or it processes something and gives you something back in the console. Up to this point, we have not used any extensions to the Python library. So let me explain how this works. There is something which is called the standard library. So there are many pre-set functions that you can use that are already built into the Python interpreter, but they're not loaded by default. You need to import them if you want to use them. So to give an example, if you want to work with the things with the OS, you can do, for instance, an import by typing import OS, and that will load the OS module. This is part of the standard library, so you don't have to install anything extra for it. When you install Python, this is already included among many other libraries. So once you have imported a library, you can start to use it. For instance, you can see if a file exists, for instance. So you can do OS, that's part of the OS library, OS, and then path exists. So here path, and then you can do is file, for instance, is file, and then you can type the path of a file, and then if if it's a file, it will be returned. So let's see, what do I have here on my desktop? The lorem ipsum, that's a file. So if we say desktop dash lorem ipsum text, there we go. Oh, lorem ipsum.txt. This is a file, so if I press enter now, then it should return true. So there you have it. Now I've confirmed that this file exists and that it is actually a file. So that's one of the functions that is already built in the OS module. So there are many more modules. If you press F1 while you're in the console, in the idle console, then the help page should open. F1, there we go. Oh, I have to be in it. F1. Let's go and see, go to help, Python docs, Control H it says. That works for me as well. So Control H brings you to the Python documentation, where you can find all the tools that are already built in, library reference, and there's built-in functions. These are built-in functions that you can call without importing modules. So we've already used, for instance, the sum function. There we go. Sum function. You can read up here about it. So if you go back. So let's talk a little bit more about modules that you can import. If you want to see which models are available, you can press Ctrl H from within the console, the idle console, and then it will open the Python documentation of your version in the browser, in your default browser. Here you can find and look up all kinds of things about Python, like the history and license of Python, etc. I suggest you take a look at that. But at the right hand corner there's a modules link, so if you click there you will go to a list that lists, well, all the modules that are included in Python in the standard library. So if we scroll down to the O, then here we'll see OS and OS path. That's the one that we've used before. So you can click through there and you can look up what's available, how it works, and it's quite extensive, and most of them you will not use immediately, but over time you will learn the most important ones. So that's where you can look up all the modules that are available, and I suggest you take a look at that. If you are working on, I wanted to explain you about the standard library, and I wanted to show you some examples of how to use it, and I wanted to show you some overview. So I had to look up in the documentation the standard library, and then I came across a brief tour of the standard library. I'll add this link to the description of this video, so you can look it up yourself. And here you see some examples of what's available. So we've already seen import OS, and then with os.getCwd means current working directory, how it says here, it will show you in which directory you are. So if we try this ourselves in the console that we have open, so we have already imported OS, and if we do os.get current working directory, then it will show you my home directory. So that's where we are currently at. So let's see what else they have. Dir OS returns a list of all modifiers. Yes, that's also interesting to show you. If you use the dir command on a module, it will show you all the available functions that are under it. So let's walk through this quickly. So we've, like for instance, the change dir command, chmod command. Change dir command is to change the directory. So if we do os.change dir, and then let's go to the desktop, for instance, desktop, and then if we check for the current working directory, we are at the desktop. So from within Python you can manage your operating system or the file system with this module. Okay, so if you, I think you should research the documentation yourself and see what's available. We will get to more of the modules at a later point. And for now, one of the specific things about Python is also that Python uses code indentation. So let me show you that. So I want to show you about code indentation. That's something that's typically something for Python, which makes it different from other programming languages. So I thought I'd just show you some of my code, so you can get a feel for it and understand what I mean. And at the same time, you can also see how the import of modules what it looks like. So this is a piece of code that I've written. It's for a website, and you can see that some libraries are being imported. Like for instance here, the regular expression library, which is part of the standard library, math for doing mathematical operations, iter tools for the time module, etc., etc. So that's what the imports look like, and the indentation is what you see here. So instead of using brackets, what you see in some programming languages like brackets like this, Python uses indentation. And so if we go to the next line here, let's say we define something like a function x, and then instead of doing what you do in some languages, you do like this, and then you start typing something. And at the same time you could also define it like this, and then usually they have a semicolon to say this is the end of the statement. Python doesn't use all these semicolons and brackets. It just uses new lines to and the indentation, which means the tabs. Or actually, these are not tabs, these are spaces. In this case, 4 spaces is one tab, and another tab is again 4 spaces. So, and this gives a clear view of how a program is structured. So, it's very easy to see where this if statement ends. It ends here. Well, if you have, if you use brackets and semicolons, you can also make your code look like this, but you don't have to make it work. And because Python makes you format your code like this, it makes it very clearly readable, and there's no other way to do it. And that's very specific for Python. So especially if you're a beginner, and you really have to program it like this, then you make your code very clear from the start. Well, if you can do it in a different way and your code still runs, then you will learn probably some bad habits. So that's a nice thing, and a very specific thing about of Python. Another thing that's very typical of Python is that it's what we call a dynamically typed and strongly typed language. Well, what does that mean? Let's have a look at that. Dynamically typed language means that if you set a variable, it will only be evaluated at runtime. So I can say, for instance, a is 1, and then at runtime the interpreter decides that a must be an integer. So I don't have to specify beforehand, like you have to do in some languages, that you have to say int a, that you have to say, okay, I want a to be an integer, please reserve some integer space in the memory. Now, you don't have to do this before, so when the program compiles, because Python is an interpreted language, So at the time that the code runs, when it comes to a is 1, at that moment the interpreter will interpret a as an integer, because it's referenced to 1, which is an integer. So that's dynamically typed, but at the same time it is strongly typed. And what that means is that if you have a is 1 and you have b is a string 2, if I do a plus b, it will give an error, because I cannot do addition with a string and an integer. Well, in some languages like JavaScript, for instance, if you do this, then the 1 will be transformed in the background from a integer to a string, and then the result will be a string of 1, 2, like so. But this can give some unforeseen bugs easily if you don't know what you're doing, because without you explicitly saying that a has to be transformed to a string, the interpreter is transforming it then. So Python doesn't do that. If you want to add these up, you have to explicitly say that 1 has to become a string. So that's the a variable. So you have to do string a. So we cast it to a string, that's what it's called, and then we do plus b. Then this will give the result 1, 2. So that's strongly typed and dynamically typed. So dynamically typed, to recap, means that at runtime the variable type will be evaluated, and strongly typed means that that the type of the variable will not be changed in the background to fit some purpose. You have to explicitly do this. Let me see, what else did I want to say about the specifics of Python. One of the things that I like about Python is this clarity, that the dynamically typedness gives a lot of freedom, while the strongly typed behavior of Python makes it that you don't introduce silly bugs, and the indentation makes the code very readable. So those are two very good things that I like about Python. And what I also like about Python is the way of thinking about how to code, and I will introduce you now to the Zen of Python, which are 20 lines statements that might not make too much sense at this time, but if you are programming for some time, you should read this again, and then it will make some sense. And I will highlight a few of the statements. You can read the Zen of Python by typing import this. It's a kind of Easter egg in the interpreter, and then you see this Zen of Python. Well, I'm not going to read through all of them, but the ones that I do like is readability counts. So that has a lot to do with the same philosophy that's behind the indentation. So it's more important to have readable code than have really condensed code. Sometimes you want to write codes that's short, but if this means that readability becomes less, then it's better not to do this. And I like that one very much. In the same way, there should be one, and preferably only one obvious way to do it. So if you're writing code all by yourself, you might figure out your own ways of doing stuff. But if you write code in a team, this becomes very critical. That it makes it easy for to have one way of working that everyone follows. And the line beneath that is also interesting to me personally because I'm Dutch. So it says there, although that way may not be obvious at first unless you're Dutch. It's a reference probably to the creator of Python, Guido van Rossum, who's also Dutch. So it's an interesting way of looking at the world. So I suggest from time to time while you're programming, you read through these statements, and it will become more clear to you what they mean, and you will start to understand the deepness of it. Okay, so this was about Python and what makes it different from other programming languages, and I hope you found this interesting. If you did, please leave a comment below and give it a thumbs up, this video, and I'll see you in the next video.